Every year, hundreds of climbers attempt to summit Mount Everest. Many of them begin in the valley below, where the most popular starting point is the town of Lukla, already at an elevation of over 9,000 feet. And by the time they finally reach Everest Base Camp, they've already skipped more than half of the climb from sea level, which made me wonder, what is actually the highest climb on Earth? Because when you subtract the elevation from Lukla, climbers still have to gain 19,000 feet vertically just to reach the summit. An absolutely massive climb, but surprisingly, Everest is not the only mountain that rises thousands of meters above the terrain around it. Take Denali, for example. At 20,310 feet, or 6,190 meters, Denali is nowhere near as tall as Everest. But what makes the mountain so intimidating is how suddenly it rises from the landscape around it. The base of Denali sits only a few hundred meters above sea level, which means climbers have to gain well over 5,000 meters vertically to reach the summit. And because Alaska is so flat around it, the mountain feels absolutely enormous. In fact, many climbers consider Denali physically harder than Everest itself. But Denali is far from the only mountain like this. In northern Pakistan, Rakaposhi rises almost directly above the Hunza Valley below it. The summit reaches 7,788 meters, or 25,551 feet, while parts of the valley floor sit barely above 1,500 meters, which means the mountain gains more than 6,000 meters, or nearly 20,000 feet of elevation in an incredibly short horizontal distance. And unlike Everest, where nearby peaks and plateaus slowly build toward the summit, Rakaposhi feels sudden, almost violent. From certain parts of the Karakoram Highway, the mountain looks less like part of a range and more like a gigantic wall erupting straight out of the valley floor. But even Rakaposhi may not be the most dramatic example. Further south, Nanga Parbat rises more than 7,000 meters or 23,000 feet above the Indus Valley below it. An absolutely absurd amount of vertical relief. The mountain is so massive that from the valley floor, climbers are staring almost directly upward at an entire Himalayan giant towering above them. And this is exactly what started making the question difficult. Because even when a mountain rises thousands of meters above the land around it, climbers still almost never begin at the true bottom. They begin where the expedition begins, and that is usually already high in the mountains. On Everest, base camp sits at around 5,364 meters, or 17,598 feet above sea level. That is already higher than Mont Blanc, higher than the Matterhorn, and higher than almost every famous mountain in Europe. On K2, the usual base camp is also around 5,000 meters, or about 16,400 feet, before the real climbing even starts. On Aconcagua, the highest mountain outside Asia, the normal base camp at Plaza de Mulas is around 4,300 meters, or 14,100 feet. Even Denali, which looks like one of the strongest contenders because it rises so dramatically from Alaska, is usually climbed from the Kahiltna Glacier. That airstrip and base camp are already around 7,000 to 7,200 feet above sea level. So the deeper I went into this question, the more artificial the starting point became. Base camp is not the bottom of the mountain. It is just the point where humans decide the climb officially starts. And that matters a lot. Because on some 8,000 meter peaks, the difference between base camp and summit is only around 3,000 meters, or less than 10,000 feet. Still brutal, still dangerous, but nowhere near the full height of the mountain above sea level. Even the lowest major 8,000 meter base camps are already incredibly high. Nanga Parbat's Rupalside base area is around 3,600 meters, or almost 12,000 feet, and that is considered low by Himalayan standards. So if base camp is not the real beginning, and the valley below is not always the real beginning either, then where should the climb actually start? That is where the entire question changes. Because if we are trying to find the highest possible climb on Earth, maybe we should stop asking where climbers usually start, and start asking where they could start. And once I looked at it that way, the answer suddenly seemed obvious. Sea level. Because that is the lowest natural point from which a person can continuously travel all the way to a mountain summit under their own power. And once you establish that, every road eventually points back toward Everest, Because no matter how dramatic other mountains may rise above their surroundings, nothing on Earth reaches higher above sea level than Everest itself. From the ocean to the summit, the mountain gains 8,848 meters, or 29,032 feet vertically, an almost unbelievable amount of elevation. To put that into perspective, commercial airplanes usually cruise at only around 35,000 feet above sea level, which means a full sea level ascent of Everest gains nearly as much vertical height as a jetliner during flight. And then I discovered that people had actually attempted the entire journey. In 1990, Australian mountaineer Tim Macartney-Snape decided to attempt something nobody had ever completed before: a true ascent of Everest from sea level to summit entirely under human power. He began at Harwood Point on the Bay of Bengal on February 5, 1990, actual sea level. From there, he started walking north toward the Himalayas. And the scale of the route is difficult to understand until you look at it on a map. Before even reaching Everest Base Camp, Macartney-Snape had already traveled more than 1,200 kilometers, or 750 miles across India and Nepal. The route crossed crowded cities, farmland, rivers, forests, and eventually the foothills below the Himalayas themselves. At one point, he even had to swim across the Ganges River during the approach north. And unlike modern Everest expeditions, the mountain was only the final section of the journey. For weeks, the altitude increased almost invisibly. A few meters here, a few hundred there. Then, eventually, roads turned into mountain trails, villages became sparse, trees disappeared, and the route slowly transformed into a Himalayan expedition. By the time Macartney-Snape finally reached Everest Base Camp, he had already completed a journey longer than the entire length of the many countries, and then he still had to climb Everest. What makes the expedition even more unbelievable is how he climbed the mountain itself. No supplemental oxygen, no Sherpa support above base camp, and no large guided expedition. On May 11, 1990, after more than 3 months of continuous ascent from sea level, Macartney-Snape reached the summit of Everest and became the first person in history to complete the full sea level to summit ascent entirely under human power. And what surprised me is that the idea did not end there. Since then, several climbers have attempted their own versions of the route. In May 2026, Oliver Foran set a new speed record for a human-powered sea to summit ascent, cycling more than 1,150 kilometers from the coast of India before trekking to Everest and reaching the summit in exactly 50 days. Just a year earlier, Andrew Ushakov completed a completely different speed-focused version, traveling from sea level in New York to Everest summit in just 3 days, 23 hours and 7 minutes, although much of the route involved air travel. And in 2025, Bangladeshi trekkers Ikramul Hassan Shakil and Shakil Ahmed walked more than 1,400 kilometers from the coast of Bangladesh all the way to the summit of Everest, which means Everest from sea level is no longer just a strange mountaineering idea. It has become its own category of ascent. But technically, sea level is not the lowest place on Earth. And once I realized that, the entire question broke again. Because the shoreline of the Dead Sea sits around 430 meters, or 1,410 feet below sea level, making it the lowest exposed point on the planet, which means Everest from sea level is not actually the highest possible climb on Earth. The real number would be even larger. From the Dead Sea to the summit of Everest, the total elevation gain becomes more than 9,200 meters, or over 30,000 vertical feet, and what makes this even harder to understand is the scale of the route itself. A realistic overland journey would likely stretch well over 6,000 kilometers, or nearly 4,000 miles across Asia, starting in Jordan, then gradually climbing north and east through countries like Syria, Iraq, Iran, Pakistan, India, and finally Nepal, before even reaching Everest itself. And for most of that route, the elevation gain would be almost invisible. You would begin in the lowest exposed place on Earth, surrounded by desert cliffs that already tower above you. Days would pass with barely noticeable elevation change, and only near the very end of the journey would the terrain finally begin transforming into the massive mountain wall of the Himalayas. Which means the climb to Everest would no longer just be a mountain expedition. It would become a gradual ascent across almost an entire continent. And honestly, at this point, the question felt solved. And in 2005, a group of climbers actually decided to attempt exactly that. The expedition was called EverestMax. On December 21, 2005, the team departed from Jordan near the shores of the Dead Sea and began traveling east toward the Himalayas entirely under human power. What followed was one of the strangest Everest expeditions ever attempted. Before even reaching the mountain itself, the team cycled more than 8,000 kilometers, or nearly 5,000 miles, across Jordan, Syria, Turkey, Iran, Pakistan, India, Nepal, and Tibet. For almost 5 months, Everest was not even visible. Most of the expedition was spent crossing deserts, highways, massive plateaus and mountain passes across the width of Asia, while slowly gaining elevation the entire time, and that gradual ascent is what makes the expedition so difficult to comprehend. A normal Everest expedition begins with a flight into the Himalayas. This one started in the lowest exposed place on Earth and never stopped climbing. And remarkably, multiple members of the expedition actually completed the entire route. Pauline Sanderson reached the summit on May 18, 2006, becoming the first person in history to complete the full human-powered journey from the Dead Sea to the summit of Everest. Just 2 days later, Austrian adventurer Gary Winkler reached the summit independently as part of a friendly rivalry with the EverestMax team. Dominic Faulkner and Jamie Rowan followed on May 21st after completing the same overland route. By the end of the expedition, the team had completed a continuous ascent of more than 9,200 vertical meters, or over 30,000 feet, from the shores of the Dead Sea to the highest point on Earth. And honestly, at this point, the mystery no longer felt like a mystery. This had to be the highest climb possible on Earth. But if the Dead Sea works only because it is below sea level, then the next question is obvious. Are there any even lower places on Earth from where you could begin the ascent of Everest? And the first idea that came to mind was caves. Because some cave systems on Earth go more than 2 kilometers underground. Surely that would beat the Dead Sea. The strongest candidate is Veryovkina Cave, currently one of the deepest known caves on Earth, reaching a confirmed depth of around 2,209 meters, or 7,247 feet underground. At first glance, it completely destroys the Dead Sea answer. The Dead Sea is only around 430 meters below sea level. Veryovkina is more than 5 times deeper. But then I checked the actual elevation of the cave entrance, and that changes everything. Because the entrance to Veryovkina Cave already sits at around 2,285 meters, or 7,497 feet above sea level in the Caucasus Mountains, which means even after descending more than 2.2 kilometers underground, the deepest explored point of the cave is still slightly above sea level, around 76 meters or 249 feet above it, to be exact. And suddenly, the entire cave idea falls apart, because for this question, underground depth does not actually matter. As far as we know, there are currently no known cave systems on Earth that actually descend lower below sea level than the Dead Sea itself. At least not ones humans have discovered and explored, so unless we eventually discover a deeper cave somewhere underground, or dig one ourselves, the Dead Sea still seemed like the best possible answer. But then, that raised another question. What about human-made depths? Because humans have drilled and mined far deeper underground than any known cave system. So what is the lowest place on Earth where a person can actually stand? And the answer turns out to be a mine in Canada. Kidd Mine reaches roughly 3 kilometers below the surface, placing some of its deepest working levels around 2,700 meters, or nearly 9,000 feet below sea level, which suddenly makes the Dead Sea look tiny. Because if you could somehow begin an Everest ascent from there, the total elevation gain would exceed 11,500 meters, or nearly 38,000 feet, higher than cruising altitude for many passenger aircraft. But there is one massive problem. You cannot realistically walk continuously from northern Canada to Everest. Even if you somehow cross the Bering Strait, large parts of the Arctic route would be nearly impossible to traverse on foot. You cannot realistically turn Kidd Mine into one continuous human route to Everest. So I needed to find the lowest place humans can actually reach that is still connected to Everest by land. And that brings the answer to South Africa. Mponeng Gold Mine, southwest of Johannesburg, is one of the deepest mines on Earth. It reaches almost 4 kilometers below the surface, and published mine data places its deepest level around 2,062 meters, or 6,765 feet below sea level. Humans are not just theoretically able to go there. This is a working mine with ore mined thousands of meters underground. Getting down there normally means using mine elevators and underground transport. A trip to the deepest levels can take over an hour. And to be clear, I would not claim there is one clean emergency ladder from bottom to surface unless we confirm it. But physically, this is a human-accessible underground environment, and if someone wanted the purest possible version, the first part would have to be climbed out through mine workings, shafts, ladders, or ropes where access is possible. From there, the route becomes absurd. You would start more than 2 kilometers below sea level in South Africa, then cross north through Botswana, Zambia, Tanzania, Kenya, Ethiopia, Egypt, Israel, Iraq, Iran, Afghanistan, Pakistan, India, and Nepal before finally reaching Everest. Using a conservative waypoint route, the straight line segment total is about 12,900 kilometers, or 8,015 miles. The real walking route would be longer, but that gives the minimum scale of the journey. And then, the vertical number is the real punchline. Everest is exactly 8,848.86 meters, or 29,032 feet above sea level. Add Mponeng's 2,062 meters, and the total elevation gain becomes 10,911 meters, or about 35,797 feet. So the final answer depends on the definition. The clean natural answer is Dead Sea to Everest, but the most extreme human accessible answer I can find is Mponeng Gold Mine to Mount Everest summit. As far as I can find, nobody has ever done it. So, are you up for the challenge?